So I'm Karen, and I'm going to tell you about the project that my team worked in the last 3 months trying to optimize the delivery of emergency medical services in Cincinnati, Ohio. Now, I'll start by saying that emergency medical services, also from my personal experience as a medic, is a very crucial process in which every second matters. And in the city of Cincinnati, a city of 300,000 residents, last year there were 74,000 incidents. In most of these incidents, the paramedics arrived to the scene and took care of the patient. But in 30,000 of them, the patient had to be transferred to the hospital. In Cincinnati, they have 50 EMS vehicles, all equipped to provide medical care. But only 12 of them are ambulances that have the capability to transfer the patients to the hospital. So as you can see, this is kind of a scarce resource. So the dispatcher has to make a snap judgment whether to send an ambulance or not to an incident. Currently, the dispatchers have this fixed table that for each incident type, they have a row that says, for this code, we're going to send this vehicle. And when a 911 calls come in, the call taker gathers the information about the incident, and according to this information, it translates into a code. Code is then sent to the dispatcher that says, okay, this is the code, this is the response I'm going to send. Using this system, last year, out of the 74,000 incidents, in 55% of them, the code said that you don't need to send an ambulance. So the dispatcher just sent the other vehicle. But in 27% of these cases, when the paramedics arrived to the scene, they decided that the patient needs to be transferred to the hospital. So the dispatcher then sent an ambulance. This means that 50% of the cases got delayed hospital transportation. It doesn't sound as much, but that's more than 10,000 people that got to the hospital later than they could have. This is where we partnered with Cincinnati this summer to try to reduce this number. So we suggested to them that instead of just using this fixed model, this fixed table, they can incorporate a model, a machine learning model, in which they don't only look at the code, but they also incorporate other information. For example, the history of the past incidents with this code. What happened there? Did they have to transport the patient to the hospital? When does the incident happen? Is it during the day? Is it during the night? Middle of the week? Weekend? What is the weather? Is it heavy rain? Heat wave? Where is the incident happening? What is the demographics of this neighborhood? What is the average age there? And also, of course, we wanted to introduce some constraints. There are some incidents and where we don't want to take any guesses and we don't want to use the model, and we want to send ambulance no matter what, such as cardiac arrest or stroke. Currently, they have 15% delayed hospital transportation. We were able to reduce this number using our model to 11.7%. This means that 2,440 people per year can get faster to the hospital and can get the treatment that they need faster. And for some of them, that could be the difference between life and death. Thank you.